Hi, good morning. Today we're going to continue with chain rule. So since we are going to focus more on the free response question, so in the free response question, most likely the chain rule question will be a little bit harder than the one that you may see in the multiple choice. So we're going to review it for one more day. So let's take a look at number one. We're going to begin with a simple question. So we got the table on the left side. We had to use the table to complete question 1 to 3. Number 1, h of x equal to f of g of x. And then you find the h prime of 6. So we have the outer function f and the inner function g of x. So the chain rule tells us to find the derivative of the outer, which is f prime, and you keep everything else the same. As soon as you finish the inner, you multiply the derivative of the inner. So basically it's the derivative of the outer function multiply the derivative of the inner function. So we finished the h prime of x. Now you got to find the h prime of 6. So we put h prime of 6 and we replace the x by 6. Now we're going to use the table to find the value g of 6. So we go to g and we go to 6. Okay, so we get g in the x value 6, and then we got 6. So we're going to replace the g of 6 by 6. Now we're going to find g prime of 6. G prime of x, and then you match with the 6. Okay, 6 and g prime, so we get 3. So times 3. Now we had to find f prime of 6. So f prime is right here, and then 6, so we get 4. So we got 4 times 3. And then the final answer is 12. So this will be one of the easiest questions in the chain rule with symbolic form. Now let's take a look at question number 2. So now we have a little bit harder question, but it's still not very difficult for you guys if you pay attention. So let's take a look at number 2. So we have h of x equal to g of square root of x. So we have the outer function is g, the inner function is square root of x. Part A, find h prime of x, and part B, find h prime of 16. So now we are going to rewrite this over. So h prime of x. So you still have to find the derivative of the outer function, multiply the derivative of the inner function. So the derivative of the outer is g, so g prime. So everything stays the same. You copy the square root x. And then you multiply the derivative of the inner function, which is square root x. So if you can find the derivative of square root x in one step, is good. If you cannot, so you can rewrite it over here, y equal to square root x. That means y equal to x to the half. Then y prime equal to 1/2, x to the 1/2 minus 1. We reviewed that before. So you get 1/2 times x to the negative half. And rewrite this into a fraction form. So 1/2 times 1 over square root of x. And then you get 1 over 2 square root x. So one more time, if you can do this in one step, you don't have to show this. So now it becomes g prime of square root x times 1 over 2 square root x. So we finished part A. Now we're going to use this to find part B. So every time if you need to find h prime of a number, you have to find the general one first. And now you substitute the value, h prime of 16. So now we're going to substitute g prime. You get square root of 16 times 1 over 2 square root of 16. So now we're going to simplify. Square root of 16 is 4, so it becomes g prime of 4. And over here we get 2 times 4. Now g prime of 4, you had to use the table because we had to use the table to do 1, 2, 3. So you're going to find g prime of 4. G prime and then 4. G prime of 4. So you're going to be 1/2. So now we're going to substitute 1/2 and we simplify from here. So you get 1/2 times 1/8. So we got 1/16. So we finished question number 2. Let's take a look at question number 3. Question number 3. So you have h of x equal to e to the f of x, and you have to find the x prime of 4. So we say that if you have to find the x prime of 4, you have to find the general one first, which is x prime of x first. So it's e to the f of x. So you think about e to the u. So you think e to the u. So we say the derivative of e to the u will be e to the u times u prime. So in this case, you get e to the f of x. F of x is the u, and then you times f prime. So you match. U is f. So e to the u times u prime, it becomes e to the f of x times f prime. So now we finished finding the general, the derivative. Now we're going to substitute x equal 4. So you get h prime of 4 equal to e to the f of 4 times f prime of 4. So we have to use our table to do 1, 2, 3. So f of 4, f equal to 4, you get 0. So it becomes e to the 0. F prime of 4, f prime, and you go to 4, you get 7. So we got e to the 0, you got 1. 1 times 7 is 7. So we finished question number 3. Okay, don't forget to memorize this formula. Okay, so one more time, your AP exam is going to be online and you have to do it at home. Most likely you're going to do it in front of your own computer, or you're going to use a phone to do it. It is an open book test, but sometimes if you don't memorize the formula, even though you have the books in front of you, it may not be very easy for you to look for. So I suggest you to memorize all this formula. Now let's go to question number 4. Number 4, we had g of x equal to h of sine x, and h prime of 0.5 equal 10. Part A, find g prime of x, and part B, find g prime of pi over 6. So number 4, we have g of x equal to h of sine x. So to find the g prime of x, so you're going to do the same thing, the derivative of the outer, which is h. So you write h prime parenthesis. And the inner function is sine. So you put sine x. And immediately you multiply the derivative of sine. If you remember, you can write it directly. So it becomes h prime of sine x times cosine x. So we finished part A. Now we're going to do part B. G prime of pi over 6. So now we're going to do substitution. You get h prime of sine pi over 6 times cosine of pi over 6. So we know that sine pi over 6 is going to be a number, and cosine pi over 6 will be a number also. So now we're going to review our special right triangle. Okay, pi is 180 degree. So pi over 6 is going to be 180 divided by 6 is 30 degree. So you have to use the 30 degree and a 60 degree. So this is the one that looked like in your SAT exam. Okay, so now you got 30, that is the smallest angle. So when it's facing it, you put 1 or 1x. And then the hypotenuse, you put 2 or 2x. And then you come from the Pythagorean theorem. Okay, 2 square, okay, which is 4. 4 minus 1 square, so you got 3. So you take the square root of that, so it becomes square root of 3. Of course, you can use this one also, okay, if you like to use the one with the x. So 1x, 2x, x squared 3. So now you have to find the sine pi over 6. That means sine 30 degree. Sine 30 degree, so you're going to be 1 over 2. So we get h prime of 1 over 2. Now we have to find cosine of 30 degree. Cosine 30 degree, so you're going to be square root 3 over 2. So we get square root 3 over 2. Now you get h prime of a half. Now let's take a look at the given. H prime of 0.5 is 10. So that means you have 10 times square root of 3 over 2. And then you simplify from here. So you're going to get 5 square root of 3. So the final answer is 5 square root of 3. So we finished question number 4. Let's take a look at question number 5. Number 5. You get p of x equal to the g of x holding square and plus f of x. Find p prime of x. So basically find the derivative. So we're going to say p prime of x. The outer function is something square, so therefore we'll bring the 2 outside, and then exponent subtract 1. Whatever inside stay the same with g of x. As soon as you write down the inner function, immediately you find the derivative of the g of x, which is g prime of x. Now you put plus. What is the derivative of f of x? F prime of x. So this is going to be the derivative. We can simplify a little bit. So we're going to have 2 times. So you get g of x to the first power, so g of x, and times g prime of x, and plus f prime of x. So this will be the final answer for number 5. So we finished question number 5. Let's go to question number 6. Number 6. Number 6. So we are going to have to find the p prime of x and then p double prime of x. So now p of x equal to e to the kx. In this case here, k is a constant. So now p prime of x. So we say that if we have y equal to e to the u, y prime equal e to the u times u prime. So u is kx. So we had e to the kx times k. K is a constant. And then plus, what's the derivative of f of x? Which will be f prime of x. And then we finish this. Of course, you can rewrite the order if you want to. So k times e to the kx plus f prime of x. Now, part B, we have to find p double prime of x. That means the derivative of the p prime. So now we're going to find the second derivative. K is a constant, it's the number, it stays the same. Now we're going to apply this rule again. Y equal e to the u, then y prime equal to e to the u times u prime. So we got e to the kx times k. What is the derivative of f prime? F double prime. So we found the answer. Of course, you can simplify a little bit. K times k will be k squared times e to the kx m plus f double prime of x. So we finished question number 6. Let's go to question number 7. Number 7, it says that z of x equal to sine mx times g of x by z prime of x. M is a real constant. So we have a product over here. So we had to use a mean rule with a product rule. Okay, so we get z of x equal to sine mx times g of x. So we have to use the product rule as the mean rule. So u equal to sine mx and v equal to g of x. U prime, so now we have to use a chain rule over here. The outside is sine, inside is mx. So we had cosine something. Now we're going to put mx inside. As soon as we finish, we find the derivative of this will be m. And what's the derivative of g? It will be g prime. Now we're going to use the product rule. So z prime of x. Okay, the product rule is u prime v plus uv prime. This multiply this first, and then you're going to add. Now we are going to get cosine mx times m and times g of x, and plus sine mx times g prime of x. So we finished question number 7. Let's go to question number 8. Number 8. F of x equal to e to the sine x. Find the x coordinate at which f prime of x equals 0 on the closed interval 0 to 2 pi. So first you define the f prime of x and make it equal to 0. So we get f of x equal to e to the sine x. That means e to the u. So we had to use this formula again. Now f prime of x, e to the u, so e to the sine x. What's the derivative of sine x? Cosine x. So we finish e to sine x times cosine x. We're going to make it equal to 0. We get two factors. E to the sine x equals 0, cosine x equals 0. So we talk about this. E to anything never equal to 0. So this part, no solution. Or if you try to do ln, you find out ln 0 doesn't exist. Also will lead to the conclusion, no solution. Cosine x equal to 0. You're not allowed to use calculator. So we use the technique that we mentioned before. You're going to use the graph 0 to 2 pi. So you chop it into 0 to pi, and then to 2 pi, and then you chop it again. So you partition into pi over 2. This is going to be 3 pi over 2. And I asked you to memorize one cycle of the cosine function, so you had to remember. Okay? So now this is cosine x. Cosine x equals 0 at these two numbers. X equal to pi over 2, x equal to 3 pi over 2. So we found the answer. Find the x coordinate at which f prime x equals 0. So these are the two x value. Okay, so we finished today's lesson. So I want you to go to do the practice questions.